Hello React Native developers, what is going on? In this episode, we get drawn by fancy Bezier curve animations, but what will keep us hooked is a sophisticated gesture handling. So welcome to Can It Be Done in React Native? This week, we swipe with style. Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this week's episode, we are looking at the liquid swipe effect built by the Cuberto design agency. Incredible design agency, and they have built this absolutely beautiful effect where you can swipe content and you have this beautiful wave that animates and follows the finger, and you have also like mask between the top and the back and front content, which just looks absolutely incredible. I'm pretty excited about this example because the very first time I saw it, you obviously immediately ask yourself, can it be done in React Native? But the very first time I saw it, I had absolutely no idea how it could be done. I didn't even know what I was looking at in terms of primitives and so on. But now, a couple of months later, and after building all these previous example, we start to get pretty good idea actually on how it's done. Plus, the code is actually open source, so we can see in Swift how it's done. It's done in Swift. So, and I'm pretty also excited because string animation values. So here you see this wave. It's obviously a Bezier curves that animates. And the way we will do it in React Native is by animating an SVG path, and so meaning animating a string animation values, because path in SVG are a string, and we used to have only support for string animation values in iOS, but since the latest release of React Native Reanimated 1.30, we can equally animate strings on Android and iOS. This means that now we can do SVG path morphing or such a Bezier curve animation on Android and iOS. So I thought a good way to celebrate such release is to tackle such an example. So how would we do this in React Native? Well, first of all, we do have access to the source code of such an example, and we can have a look. So we have the wave layer class, which is simply the Bezier curve that we're going to animate. So you see the curve here is, it's a sequence of curves plus some lines to close the curve, which we have here, and these three lines here. And so we can, using SVG, build such a path, and we can also animate such a path with React Native Reanimated. And so you see here, these are the animation parameters: wave center Y, horizontal radius, vertical radius, and side wave. So wave center Y is the position on the figure in the Y axis. You have the horizontal radius, vertical radius, and the side wave is obviously how far you are away from the screen. So this path, we can translate it into a SVG path, and we know how to animate it according to these animation values. Now, if we look at the liquid swipe container controller, we have at the bottom the functions that control these parameters we've just seen. So we have horizontal radius, which takes as parameter of progress, so from 0 to 1. So same basically for every parameter, or back radius. So I'm going to talk about it later, vertical radius. So side wave as well. So these parameters that we need to animate the wave are all controlled by a progress animation values that, if we look again at the source code, that goes from 0 to 1. So we have this Bezier curve. We have a progress animation value that goes from 0 to 1, and this is going to drive the animation. Now we need to have a gesture that drives this progress animation value from 0 to 1. And again, if we look at so we can use the gesture handler, but if we look at the source code, we'll see that the full, so there is, so if I go back here, there is horizontal radius and horizontal radius back. So meaning that when we swipe here from the right to the left, the radius value is different than from when we swipe from right to left. And also the progress animation value is different from one direction to the other, because when you swipe back, the gesture controls the progress animation value from 0 to 1, but when we swipe from right to left, it's only from 0 to 0.4, so meaning doing a full swipe animates the progress animation value only to 0.4. You release the gesture, we need to snap to one of the position. And then on the y-axis, we just simply have the gesture that follows the finger. So we have the SVG path. We know how to parameterize the SVG path. We need to link the gesture to the progress animation value. So, and we need to know also if we swipe from left to right or right to left. And then you see that the content is using a mask, right? So that's how, you see like the two images are clipped on top of each other. And so on iOS, we would use a masked view iOS. And there is now a masked view component, which works on both iOS and Android. Unfortunately, using this component, we cannot animate the masked element. So this wouldn't work actually. And so the way we would do it, I think for Android, is to have the content in SVG and use a clip path to have the content, so I have to have a nice masked view that works also on Android, which is actually a pretty big trade-off, because for instance here you have text, and the text is going to be very hard to present, in a way that is as flexible than if you were using the text element from React Native. So that's a pretty big trade-off actually. But that's pretty much how we would do it. So this is not your typical can it be done in React Native example, because so first of all, we usually look at a real world example. This is more like a prototype. And in order to explore and achieve this prototype in React Native, we are making a lot of trade-offs, and namely using an SVG clip path on Android. So we will look at it a bit later. But still, I think a very fun example to look at, and really shows some the new capabilities in Reanimated to animate strings. And also another aspect of this is that you have some sort of pagination. So right, you go from one content to the other, and this we won't cover it yet because it's going to be a bit too much for this episode, but it's something we might look at a little bit later. So more a proof of concept than anything else this time. But what do you guys think? Can it be done in React Native? Let's have a look. And before we get started, one thing, if you are interested to learn the fundamentals of gestures and animations in React Native, you can check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences that run at 60 FPS, even on low-grade Android devices. So I hope you check it out at startreactnative.dev. So here I have my boilerplate project, which you can download from the video description in case you want to follow along with this example. And in this boilerplate project, I translated some of the Swift code to React Native and reanimated source code. So for instance, we had this wave class, which is receiving 4 parameters. So center Y, horizontal radius, vertical radius, and side width. And then we use these to parameterize some Bezier curves. And so I simply, translated all the Swift code to this reanimated function. So I created some helpers to transform a command into a SVG path. And yeah, and then I just simply show the path into an SVG. And so you see the result on the right side looks pretty good. And then we've seen also from the Swift code that these 4 parameters are actually computed from a single one, which is progress, which goes from 0 to 1 or 1 to 0. And I put it into the wave helpers. So again, you have these 5 functions, which are simply me translating the Swift code into reanimated code. And the way I do it, because you see you need to to be careful not do any mistake. So the way I did it to make sure I did the translation, without forgetting a minus somewhere or getting confused about some operations. So I do it once for one function. I do it again, and then I do a diff. So if the 2 functions are identical, I have a good, I'm pretty confident that I didn't do the same mistake twice, so therefore the code should be correct. And if not, I redo it again. So that was not even that laborious, actually. It was okay. And here, so we have the 2 contents we want to display with some colors, images. And so we display the wave, which we see here. We have the content, which is, so the wave is overlaid on top of the back content. And I think the first step we can do maybe is to add the mask to display the front content. So right now the wave is black, and so maybe you can show the front content. So we are going to pass it as a children to wave. So I'm going to pass the front content. And so if I go to wave, now it receives the children as parameter. And this is where we're going to use the masked view on iOS. So this one is going to be the mask element. And we are going to return the masked view iOS children as children and mask element. And we probably need, let me check. We need to put maybe a flex one or an absolute fill. Let's have a look. Sorry. Okay, that looks good. So now let's start animating. So we are gonna wrap. So this one we're gonna wrap into a pan gesture handler. So we know that pan gesture handler takes as first children an animated view. And so pan gesture handler. And so let's create a couple of animation values. The first one we need is back. So we need to know if is back is 0 if we swipe from right to left, and 1 if we swipe from left to right. So new value. And we're gonna need Y, so the position of the finger on the Y axis, because the center of the circle follows the finger. So actually, let's start with that. Let's animate this one, and the default value is initial wave center. Perfect. And so we can create a gesture handler using the helper function from Reanimated, which is called onGestureEvent. Can pass y as parameter, and also the state of the gesture. So state is the animation value as the initial, and the initial state is state undetermined. Perfect. So we can assign it. And now we need to animate center y using this y value. And center y is going to be, we're going to create a function called follow finger or follow pointer, and we give the y value. So what we want to do is to add some inertia, because if we just assign y, I mean, let's do it actually. Let's assign y to center y, see how it looks like. So here it follows the finger, but you see it. So first of all, I mean, there's a couple of issues with it. Is that if it's at the bottom and I move my finger on top, it snaps directly. There's no animation. And then if I stop my finger, it stops immediately. So what we want to do is to add some inertia to center y. So I'm going to create a function called follow pointer. And we pass the y value as parameter. So I'm going to define this function into animation helpers. Okay, so we get as parameter, let's call it value. It's an animated node. And we're going to need, so we're going to spring the animation value to wherever the finger is dynamically. So we're going to create a clock. We're going to need spring config. So I think the spring, okay. Let me import Reanimated. So we need a clock. We need spring utils to create the default configuration of the spring. So from animated. So here we have spring utils make default config. Perfect. We need a state, right? Any animation, we need the clock, we need the config, and we need the state of the animation. And state, we have position. Oh, we need to import value as well. So we have position, velocity, finished, and time. So we have our three parameters. So what we can return is a block of instructions, and we're going to need to start the clock, and we're going to also to do some set, to do some assignment. So we want the clock to always be running, and we want to assign the so config to value to the position of finger, so to value, and we want to spring, so clock state config, and we want to return the position, so return state dot position. We need to import spring as well. Let's have a look. So no, we need to export this one and import it here from animation helpers. Let's have a look. Okay, so now you see, I mean, you cannot see my finger, but I mean, you do see already that if I go like it's at the bottom, I put my finger on top, it animates nicely to the top. So that's perfect. Now let's do the x-axis animation. So we have this progress animation value here, which we need to interpolate from the gesture. So we're going to need to look at the y gesture axis. So we're going to need translation x and velocity and I can give it as parameter here. Oops. So we're going to do this in 2 steps. First, we need to interpolate the gesture in pixels, so in translation x, into a progress value, so from 0 to 1. And once we've done that, we need to handle the case where the gesture is released, and we need to snap either to 1 or 0. So here we're going to interpolate translate x, translation x. So input range goes from 0 to max width, and max width is the width of the screen minus here this 15 pixels, which is defined in here, initial side width. So we go from 0, no, so from 0 to, so we swipe, sorry, we swipe from right to left, so we go from 0 to minus max width. So here, because we need to order it, it needs to be minus max width 0. And so max width, or actually I can move it here. Max width is simply width minus minus initial side width. Okay. And the output range is, and actually here I can put from 1 to 0 just to have a look, but we know by looking at the, I mean, let's have a look. So you see here, when I move my finger, it feels very strange because from 0, so the API defined by the liquid swipe component goes from 0 to 1, but the gesture from left to right, the gesture can only control from 0 to 0.4. And what you see here, which I'm animating the finger, is the animation that should be driven when the gesture is released. So I should only actually animate from 0.4 to 0. And this 0.4 value, you find it from the source code by looking at the source code of the liquid swipe animation. So you see here, whatever I can animate with the finger looks correct. And we now need to handle the case where the gesture is released. So progress, I'm going to rename to gesture progress. And now we need to create the progress animation node. So I'm going to call it snap progress. So we can give the value, which is gesture progress, the state of the gesture. So we need to know if we go from left to right or right to left. and we need to update this value when we snap to the opposite direction. And then we need to pass as parameter where we want to snap. Do we snap when we release the gesture? Do we snap to 1 or do we snap to 0? Which is, we're going to use snap point from redash. So it's a utility function that, given a value and a velocity and an array of snap points, will choose where to snap. So we need to give the gesture progress, and we need to convert the velocity to so we have the velocity of the gesture, but based on the screen. Here we need to convert it into a velocity, but based we interpolated translation x from a value that goes from 0 to 1. We need to do the same for the velocity value to make sense. And so we are going to divide velocity x by max width, but actually in this case it's not max width, it's max width, it's 40% of max width, so it's multiply max width by 0.4, and we need to give the snap points, which are 0 or 1. Okay, so let's create this function. So here we have animation node. Here we have value, because we're going to need to modify, once we finish snapping, we need to modify it to 0 or 1. And here we have point, which is an animated node as well. Okay, so we're gonna need also a clock, a configure. We're gonna need to spring, so we need these values. We're gonna need also an offset animation value, because we need to remember if we were at 0 or 1. And we can return a block of instructions. So actually we can return, and we will return at the end the state position. And we have a condition: is the gesture active or not? So 2 blocks of code, one if the gesture is active. So state.active. Need to make some imports here. Condition equals so now if, let's say, gesture is active, we can set state position to gesture, let's call it value here, to value. And when the gesture is not active, we need to start the spring animation. So if the clock is not yet started, so gesture is not active and not clock running, we can reinitialize the animation. So I can set state.time to 0, set state.finished to 0, and I can start the clock. Now we can spring. So spring, it's clock state config. Oh, forgot something here. I need to set config to value to point, to snap point. This is where we want to spring. Perfect. So here we execute the spring. Now, if the clock is running and the animation is over, so if state dot finish is equal 1 and the clock is running, we need to stop the clock. So perfect, but I need a couple of import and clock running, stop clock, start clock. Not stop clock, clock running, and what else? Oh, state, I'm gonna rename to gesture state. Here it's clashing. Perfect. That looks good. Let's have a look. Forgot to import this one. Okay, so here it snapped, but not, you didn't see my finger, but it didn't snap where I was expecting it. And I think it's because we go from 0 to 1. So here we are at 0. So I think I need to multiply this one by -1. Yes, it snaps exactly at the opposite direction. So let's try this one. Just doing a -1 here. Okay, so here it snaps back to position. And here, if I... No, something is off with the snapping, I think. Let me try again. Now that looks good. And you see now something is off. Something is off with the calculation of the snap point. Is back is 0. Just so multiply -1. Okay. Now I cannot snap. So here, let's see. Once we finish the animation, we need to set is back to either 1 or 0, so to wherever we snapped essentially. And I can set is back to snap point. And if we are back, here's the interpolation, because from left to right we go from 0 to 1. We need to update these values. So if is back, the interpolation is different. So here we go from 0 to max width. And we go from 0 to 1. And for the velocity, it's, if it's back, it's max width, so we are going to multiply by 1. So if is back, we multiply by 1 or by 0 for. And also, if I go to the helper functions, the horizontal radius is different if we go back from left to right or right to left. So I can also update this one. So if it's is back, it's wave horizontal radius back. If not, it's wave horizontal radius. Oh. Okay, I think because here we are back, so is back should be true, but at 0 we should be at 1 and we go back to 0. So we go from 0 to 0, 4, then the spring goes to 0, 4 to 1, and then when we swipe left, we go from 1 to 0, completely handled by the gesture. And here from 0 to 0, 4, we can snap, no, and then snap back. So you see here now we need to make the gesture interruptible. So when the gesture is active but the clock is running, we are still animating. So when clock is running, so we need to stop the clock, of course. But we also need, so we can keep in the offset where we are, because we want, we don't want when we interrupt the gesture to have a jump in the frame. So we keep in offset where we are, and if not, here position becomes offset plus value. Here we need to, when the spring is over, we need to set the offset back to 0. And because here, okay, we do add, but we only need to go from 0 to 1, right? We never need to go above these values. We're going to add a diff clamp. So I need to import diff clamp, add, and we go from 0 to 1. So let's have a look. Okay, snaps nicely from one side to the other, and you see I'm interrupting the gesture and it works perfectly. So very, very smooth, completely interruptible. You see there is no jumps from one frame to the other. Very cool. So now we can do the last step, which is to animate this button here, which you see here. And we're gonna give it as parameter, so center Y, right? Because it needs to follow this guy, and the side width. So actually I'm gonna call it, let's say X is side width and Y is center Y. Oops. So we have X animated value node, sorry. From reanimated. So we have x, y. And so here, this is what we're gonna animate. So transform, and maybe we can assign translate y should be so should be y minus the size of the icon divided by 2. Let's try. So we have sub from reanimated. Maybe I can and translate x. We can interpolate. Or let's just assign it to x just to have a look. Let's have a look. Okay, so here we need to subtract. So the y position looks good, but here we need to subtract. So the width minus the initial side width. Let's have a look. And width we get from dimensions get window. Or maybe if we go back here, so side width. So maybe it's better to actually interpolate it because I'm not sure about the values of side widths. So let's actually interpolate it from progress directly, because this one we understand the range of values. So I'm just gonna pass progress as property. And so if I go into button, so here I have progress, and progress we can interpolate. So input range goes from 0 to 0.4. Output range if we are at 0, we're in position, in this position, so it would be width minus initial side width, and at 0.4 it should be 0. So because we should be completely on the left side of the screen, so I can do interpolate. Let's have a look. Yes, so we need to remove the size of the icon. Okay, perfect. We can add some padding to it as well. So I can add maybe 8 pixels of padding. Well, sorry. So that would be, I think, a plus, right? Yes. And we can add some opacity to it as well. So which we can interpolate from the progress as well. So from 0, let's say, okay, to 0.4, here we are at 1, and at 0.4 we are at 0, but probably we're going to add 0 opacity way before the arrow touches the end of the screen. Yes. So we're going to make it way more abrupt, maybe 0.1. And here you see, perfect. It fades nicely, go back, and pops up again very nicely. Up. And back. So pretty cool, very experimental. So now let's talk about the elephant in the room, which is the Android support, because here, if I go in the wave, I'm using the masked view iOS, which only works on iOS. There is a masked view component from React Native community, which works on Android, iOS and Android. But you cannot animate the mask element. So here what we're going to do is use a clip path instead of a mask view. But this comes with a big trade-off, which is you see this content here is done using views and text, and we're going to need to use text from SVG in order to achieve this. All right, guys, so here I have the same gesture and animation working on Android. So we have also the nice snap and the view masking. And so the way I did it in order to have it working on Android and in a way that can be animated is that I used the clip path from SVG. And by the way, I mean, the work that Michael Sand is doing on this module is absolutely incredible. And so on the latest version, you can have an animated path as a clip path. And we apply the clip path to the content. And so this means that I had to rewrite the whole content to use SVG elements instead of text components from Reanimated, which has a huge trade-off because you need to do the positioning of your elements yourself and the layout. You need to do the layout manually. You cannot have a dynamic layout. And so maybe for some contents, it might be okay if you just have like an image and a title. That can be actually more than okay, or some maybe complex content, but or maybe you have some explanatory animation or something. But if you have some text like this, it becomes pretty hairy. But I just wanted to show it to you as a proof of concept. So I hope you guys enjoy this example. This was quite different from usual. This was very experimental, but here's this actually curve. So this Bezier curve animation technique is actually like pretty solid. It's just that the part which is I would say very experimental here is really the view masking. And so next episode of Can It Be Done in React Native, we'll do something a little bit less experimental based on the real world app, and we're gonna build a very solid solution. But yeah, I hope you guys enjoyed it. I'm looking forward to talk to you guys soon, and in the meantime, happy hacking.